Welcome to month 5 of the Claude Architect track, the final session, where we close the loop on production reliability. Over the past 4 months, you built the foundations of the Sail-on-Pay AI platform, reliable prompts, multi-agent systems, MCP tools, and a document extraction pipeline. Today, you're hardening all of it for production. 4 hours, 4 themes. We start with context window management, arguably the most common source of silent production failures in agentic systems. Then we cover human-in-the-loop design, how to build deterministic escalation and audit trails. In the third hour, we'll build the complete production-grade Sail-on-Pay support agent. And in the fourth hour, we review self-evaluation patterns and walk through the 5 exam domains to prepare you for the Claude Certified Architect certification. 5 concrete outcomes for this session. First, you'll be able to design context management strategies that keep production Claude agents within token limits using summarization, sliding windows, and prompt caching. Second, you'll implement multi-agent handoff protocols that preserve critical state across agent boundaries without token waste. Third, you'll architect human-in-the-loop workflows with deterministic escalation triggers, approval gates, and immutable audit trails. Fourth, you'll apply self-evaluation and confidence scoring patterns to improve the reliability of Claude's output in production. And fifth, you'll demonstrate exam readiness across all 5 Claude Certified Architect competency domains through scenario-based walkthroughs. These aren't abstract concepts. Every one of them maps to a concrete deliverable in today's challenge and to real exam questions. Every Claude API call has a hard token limit. For Claude 7.4.5 and Claude OS 4. That limit is 200,000 tokens of combined input and output. The moment you exceed that limit, one of 2 things happens. The API either truncates your message list silently or it raises an error. Neither outcome is what you want. Here's the part most developers don't realize until it causes a production incident. Truncation doesn't happen from the end of the conversation. It happens from the middle. The API preserves the system prompt and the most recent user message and quietly drops the middle of your conversation history. Your customer's original complaint, the reason they called, gets dropped. The agreement you made on turn 3 is gone. The account number they gave you is gone. Understanding your token budget is the starting point. The system prompt uses around 2,000 tokens and is a prime candidate for caching. Tool definitions add about 1,000 more. Conversation history is the risk zone. It grows with every turn and has no natural ceiling. And you always need to reserve at least 4,000 tokens for Claude's output, otherwise the model runs out of room before it finishes the answer. The fix is pre-flight token counting. You count tokens before you build the message. The Anthropic SDK provides Anthropic beta messages. Count tokens for exact measurement, or you can use tick token with the kill 100k base encoder for a compatible approximation. Your trigger should be somewhere between 60% and 80% of the model's context limit, enough headroom to act before things break. The right approach to context management is a 5-step flow. Start by counting tokens before every API call. If the history exceeds 60% of your token budget, you move to step 3. Summarize the oldest 30% of turns into a compact summary block. Then prepend that summary to the remaining history and send the trimmed result. The critical principle is this: never drop history without summarizing first. A sliding window that simply discards old turns will throw away the customer's original complaint, the single most important piece of context in a support conversation. The summarization prompt needs to explicitly instruct Claude to preserve the original complaint, any promises made during the conversation, and key facts like transaction amounts, dates, and account IDs. Pleasantries, repeated clarifications, and filler turns can all be discarded. Comparing the 3 strategies, a plain sliding window is simple and low latency, but it loses signal from early turns. Summarization preserves the most important context at the cost of 1 extra LM call per prune event. Our egg-based approach, using a vector store, enables semantic retrieval across long histories, but adds meaningful latency and is generally overkill for a support agent. Summarization is the right choice for Sail-on-Pay. One edge case worth designing for: What happens when the summary itself is too long? If you're summarizing 30% of a very long conversation, the summary could be hundreds of tokens. Include a maximum summary length in your prompt template and compress further if necessary. Prompt caching is the single highest ROI optimization you can make to a production Claude deployment. The mechanism is straightforward. You mark stable blocks in your system prompt with the cache control field set to type, ephemeral, and anthropic caches the key value computation for those blocks across repeated calls. The economics are compelling. Writing to the cache costs about 25% more than normal input token pricing, a one-time warm-up cost. Rating from the cache costs approximately 10% of normal input pricing, a 90% saving on every cache hit. For a 2000 token system prompt code 1000 times with an 80% cache hit rate, that translates to saving roughly 144 million token equivalents in billing. At production scale, prompt caching pays for itself within days. What you should cache? The system prompt persona, policy documents, tool definitions, and any fixed few short examples that don't change between calls. What you should not cache: per user context, dynamic conversation history, or anything that varies between individual API calls. In the API response, check the usage object for two fields. Cache read input tokens tells you how many tokens were served from cache, and cache creation input tokens tells you how many were written to cache on this call. If cache read input tokens is greater than 0 on your second call, the cache is working correctly. This is a real failure pattern. The Sale and Pay support agent has been running in staging for 2 weeks. Everything appears fine until conversations exceed 20 turns. Then the agent starts offering a partial refund, LKR 22,500, on a dispute that was originally LKR 45,000 and where a full refund was agreed on turn 3 of the conversation. The root cause is silent context truncation. No token counting is happening before the API call. The conversation history grows unbounded until the model's window fills up, and the API silently drops the earliest turns, including the original complaint and the agreed resolution from turn 3. The secondary failure is cost. Each conversation is costing 3 times the projected amount. The full 50-turn history is being sent on every single call with no prompt caching and no sliding window applied. The fix has 3 parts. First, add pre-flight token counting before every API request. If the history exceeds 60% of the 200K token budget, that's 120,000 tokens, trigger summarization of the oldest 30% of turns. Second, enable prompt caching on the system prompt blocks. For the Sale and Pay support persona and policy document, this alone should drop per call input costs by 60 to 70% on warm cache hits. Third, write a test that injects a 50-turn conversation history and verifies that the agent's answer on turn 50 is consistent with facts established on turn 3. If that test had existed, this bug would have been caught before staging. When Tier 1 can't resolve a customer issue, context must move to Tier 2. The challenge is doing that transfer efficiently, preserving the essential information without bloating the Tier 2 agent's context window with the full history. There are 4 handoff patterns to know. The inline summary pattern is the simplest and fastest. Pass the context summary directly in the message payload. Use this for sequential agents with short state and low latency requirements. The external store pattern uses Redis or Azure Table Storage to hold the conversation state between agents. This works well for long-running workflows where the handoff might be retried or resumed after a delay. The event envelope pattern puts the handoff payload onto a message queue, making it ideal for asynchronous workflows where an audit trail is required. The shared vector store pattern enables semantic retrieval across a large history using Azure AI Search or pgvector, valuable for research agents, but generally overkill for support. Every handoff should include a minimum viable envelope. The handoff weight is a UUD that serves as your deduplication key. It prevents duplicate Tier 2 activations on retry. The from agent and to agent fields close the audit trail. The conversation summary is the compressed context that Tier 2 actually uses. The full history ref is a pointer to the complete conversation stored in blob storage. Tier 2 can retrieve it if needed, but doesn't have to pay the token cost of loading it by default. The escalation reason tells the tier 2 agent and the human reviewer exactly why the escalation happened. The NFR for handoff latency is 500 milliseconds. That budget covers summary generation, envelope serialization, and the state store write. Summary generation is typically the bottleneck and the component most worth optimizing. Human in the loop design is about more than adding an escalation path. It's about designing the pause, the state preservation, the handover, and the resumption as first-class architectural concerns. The escalation trigger is a deterministic rule engine, not a fuzzy model. In production, you need predictable, auditable behavior. The trigger evaluates 4 signals: confidence threshold, sentiment, policy keywords, and repeat contact count, and fires on the first condition that matches in priority order. The approval gate is where the agent pauses and holds state. When escalation fires, the agent serializes the full conversation state, history, pending draft response, customer metadata, and queues an async task to the human dashboard. The agent does not send any response to the customer until a human has reviewed it. This is the key difference between human in the loop and human on the loop. The audit trail must be append only and immutable. No updates, no deletes ever. Every event needs a timestamp, the agent's decision, and confidence score, the human's action, and the final outcome. This is your compliance evidence for a payment platform operating under financial services regulations. The override mechanism deserves special attention. When a human edits Claude's draft before sending it to the customer, that change must be captured in the audit log, specifically who edited what and when. Without this, your audit trail shows what Claude recommended, but not what was actually sent. The SLA timeout is the defensive path. If no human responds within T minutes, the system should automatically escalate to a supervisor or execute a safe default action. Design the timeout path first, because it's what happens when everything else goes wrong. 4 escalation triggers must be evaluated in strict priority order, with the highest priority trigger taking precedence when multiple fires simultaneously. Policy keyword match is always the highest priority. These are legal and reputational triggers. If a customer's message contains the words fraud, lawyer, lawsuit, chargeback, police, or threat, the agent escalates immediately, regardless of confidence score, regardless of sentiment, regardless of contact count. The escalation happens before a response is generated. Repeat contact is the second priority. 3 or more contacts from the same customer in a 24-hour window on the same issue signals that the agent has failed to resolve the problem. The Tier 2 agent needs to know this is a persistent issue, not a fresh inquiry. Negative sentiment is third. You can detect this with a secondary Claude call that scores sentiment on a 0 to 1 scale, or with a faster but less accurate keyword-based heuristic. The trade-off is latency versus accuracy. Choose based on your SLA budget. Confidence threshold is the standard case. The agent self-reports a confidence score between 0 and 1. Below 0, 5. The ticket enters the escalation queue with the low confidence reason logged. A critical calibration issue deserves emphasis. A threshold of 0. 5 can escalate 80% of tickets if confidence scores are poorly calibrated. Before deploying any confidence-based escalation to production, measure the distribution of confidence scores against a labeled dataset. If the median confidence score is 0, 6 across all tickets, a threshold of 0 or 5 will behave very differently than if the median is 0, 9. Always validate thresholds empirically, not theoretically. Production reliability for an LN agent rests on 3 principles. Retry what can be retried, never retry what can't, and always degrade gracefully when all options are exhausted. Retry logic in Python is most cleanly expressed with the tenacity library. The key is using retry if exception type with an explicit tuple of retriable exception classes, rate limit error for 420 responses, epitimeout error for connection timeouts, and internal server error for 550 responses. Use weight exponential with a minimum of 1 second and maximum of 60 seconds, and stop after attempt 5 as the ceiling. Any exception not in the retriable tuple propagates immediately without retrying. The single most important point, never retry a 400 bad request. A 400 means your request is malformed. The prompt, the tool definition, or the message structure is invalid. Retrying it wastes quota and hides the bug. Only transient infrastructure failures, rate limits, timeouts, server errors are worth retrying. Idempotency is what protects you when retries succeed. Every agent task needs a unique requested before executing any action with side effects, a refund, a record update, a notification. Your code checks whether that requested was already processed. If it was, the action is skipped and the previous result is returned. Without this, a successful retrieve that calls the process refund tool twice results in a double refund. In a payment system, that's a real financial error. The circuit breaker pattern kicks in after a configurable number of consecutive failures. Instead of continuing to retry an API that appears to be degraded, the circuit breaker opens and routes all traffic to the human escalation path. This prevents runaway costs and gives the on-call team time to respond. When all retries are exhausted, serve a scripted safe response to the customer, something like, "We're experiencing technical difficulties. A support agent will contact you shortly," and escalate to the human queue. Never surface a raw API exception to a customer. The month 5 challenge is the capstone for the entire Claude Architect track. 4 deliverables, each worth 25 points for a total of 100. Deliverable 1 is the context management design document. This is a written analysis covering your token budget allocation, the sliding window and summarization design, including your prompt template, the handoff envelope schema with full JSON, and a trade-off comparison of at least 3 context strategies with quantified data. Deliverable 2 is the human-in-the-loop implementation. This is working Python code with all 4 escalation triggers implemented in priority order, context pruning with accurate token counting, a handoff envelope that validates against a Pydantic V2 model, an append-only JSON audit trail, and a working run demo. I that shows escalation firing. Deliverable 3 is the reliability test suite, 12 specific named test cases covering retry logic, escalation accuracy, context management, idempotency, prompt caching, and audit log completeness under concurrent load. Every test maps directly to one of the NFR targets. Deliverable 4 is the production readiness report. This ties together all 5 months of sell and pay architecture work, decisions made in each month, the risks identified, the mitigations implemented, and your self-assessed readiness across the 5 exam domains. The passing score is 75%. The scoring rubric rewards specific, quantified evidence. Every claim in the report needs a number behind it. The Sale on Pay support agent is composed of 5 modules with clear, single responsibilities. Support agent. I is the main multi-turn loop. It orchestrates the flow, receiving a customer message, calling context manager before the API request, calling escalation checker after the response, and routing to handoff if escalation fires. Context manager. I handles token counting, sliding window pruning, and summarization. It has one job: keep the message history under 60% of the 200K token budget before every API call. Escalation. I evaluates the 4 trigger conditions and returns an escalation decision pedantic model with the result and the reason. Handoff. I builds the handoff envelope model, writes it to the state store, and returns the envelope ID for tier 2 to retrieve. Audit logger. I writes 1 JSON event per agent action to an append only log file per session. The audit logger receives an event for every action taken by every component, normal responses, escalation decisions, context prunes, handoff writes, retry attempts, and fallback activations. Nothing happens without a log entry. This modular architecture is intentional. Each module can be unit tested in isolation. The 12 test requirement maps directly to these boundaries. You can mock the context manager to test escalation, mock the escalation checker to test handoff, and mock the Anthropic client to test retry logic without end-to-end API calls. Claude can be asked to evaluate its own output, and this works better than intuition suggests. Generating an answer and evaluating that answer are different cognitive tasks. The evaluation prompt directs Claude's attention toward gaps in edge cases that it might not have considered during generation. Confidence scoring asks Claude to rate its answer from 0 to 10 and explain the primary source of uncertainty. After normalization, a score below 0, 6 serves as the escalation trigger. The prompt should explicitly ask for the reason behind low confidence and what additional information would raise it. This gives you diagnostic data you can act on, not just a number. Chain of thought verification takes the generated answer and asks Claude to reread the original question and confirm that the answer actually addresses it. This catches off-target responses, situations where Claude answered a slightly different question than was asked. Because it requires an extra API call, use it selectively on high-stakes decisions rather than on every response. The devil's advocate prompt asks Claude to list 3 ways the above answer could be wrong or incomplete, with particular attention to edge cases in sell-on-pay payment processing. This surfaces failure modes that confidence scoring misses because they require domain-specific reasoning. Output schema validation is the last line of defense. Every structured output, escalation decisions, handoff envelopes, refund recommendations must be validated against a pedantic V2 model before any action is taken. A validation failure is treated as low confidence, escalate, or retry with a more constrained prompt. The key insight about self-evaluation: if Claude rates its confidence at 8 out of 10, but the answer is wrong, the self-evaluation mechanism is failing. This is why you need a labeled test set to validate confidence scores against ground truth. Self-evaluation is a useful signal, but not a guarantee of correctness. The reliability test suite requires 12 specific test cases, each with a defined trigger, a verified behavior, and a measurable pass condition. For retro logic, there are 4 tests. Test telemetry injects a 429 response and verifies that the agent retries up to 5 times, succeeds on the 3rd attempt, and logs exactly 2 retry events. Test timeout retry does the same for a connection timeout. Test non-retrievable 400 is a negative test. It verifies that a 400 bad request results in exactly 1 attempt with no retries. And tested important retry submits the same request if twice and verifies that the duplication log shows the 2nd attempt was skipped. For escalation, there are 3 tests. Test confidence escalation injects a confidence score of 0, 3, and verifies an escalation event appears in the audit log. Test keyword escalation puts the word fraud in the customer message and verifies escalation fires regardless of confidence score. Test no false escalation is the false positive control. Confidence 0 pig with no keywords must not produce any escalation event. For context management, there are 3 tests. Test sliding window prune verifies that after pruning, the token count is at or below 60% of the model limit. Test summary prepended checks that the summary block appears before the remaining history in the message list order. Test handoff round trip writes an envelope to the state store and verifies that tier 2 can retrieve and reconstruct the same summary. The final 2 tests are test cache hit rate, which verifies that cache rate in boot tokens is greater than 0 on the 2nd call, and test audit log no drops, which runs 100 concurrent turns and verifies that exactly 100 events appear in the audit log with no race conditions or dropped writes. The Claude Certified Architect exam covers 5 competency domains, and today's session covers the last of them. Document and data extraction carries the highest weight at 25%. That's month 4. It covers structured output generation, schema validation, multi-document pipelines, and handling ambiguous or low-quality source documents. Prompt engineering, multi-agent systems, and tool use and MCP each carry 20%. Prompt engineering from month 1 covers system prompt design, few-shot patterns, and chain of thought elicitation. Multi-agent systems from month 2 covers coordinator and sub-agent design, handoff protocols, and state management. Tool use and MCP from month 3 covers tool definitions, MCP server architecture, and function calling patterns. Context and reliability. Today's session carries 15%. It covers token management, prompt caching, retry logic, human-in-the-loop design, and audit trails. For exam preparation, 2 practice scenarios are strongly recommended. The first is designing a customer support resolution agent end-to-end, 80% first contact resolution rate, full escalation logic, and context management. If you've completed the month 5 challenge, you've essentially done this scenario. The second is designing a multi-agent research system with a coordinator, sub-agents, context handoffs, and a handoff envelope schema. Focus on the token management and state transfer details. Those are where exam questions probe deepest. Register for the exam at training. Anthropic. Come and set a date within 30 days of this session. The knowledge is freshest right now. The production readiness checklist represents the complete implementation surface for a Claude-powered application going into production. Every item is checkable with concrete evidence. API keys must be in Azure Key Vault, not hard-coded. Rate limit handling with exponential backoff must be implemented and tested. Context window management with sliding window and summarization must be active. Prompt caching must be enabled for all stable system prompt blocks, and you must have evidence from the API response that the cache is being hit. Human-in-the-loop escalation must have SLA monitoring enabled, not just the escalation logic. Idempotency keys must be attached to all tool calls with side effects. Audit logs must be flowing to Azure Table Storage with 90-day retention configured. Alerting must fire when the escalation rate spikes above 30% in any 1-hour window. A canary deployment of under 5% traffic must precede any full rollout, and a rollback plan must be documented and tested, not just described. The risk register captures the 4 most likely production failure modes. Context truncation causing wrong answers is the most probable risk. The probability is medium and the impact is high. The mitigation is the sliding window plus summarization pattern from today's session. Rate limit bursts during peak hours are a high probability risk for SalonPay, whose Sri Lankan business hours overlap with global peak API usage. The mitigation is exponential backoff plus a request queue. Human reviewer unavailability within SLA is a medium probability, high impact risk that requires the SLA timeout escalation path as mitigation. Prompt injection by a customer message is a medium probability, high impact security risk requiring input sanitization and pedantic output validation. 5 months. From writing your first reliable system prompt to hardening the production payment support agent with escalation, audit trails, and reliability testing. That's the Claude Architect track. Month 1, you mastered prompt engineering and learned to write prompts that behave predictably under adversarial inputs. Month 2, you designed multi-agent systems where a coordinator orchestrated specialized sub-agents. Month 3, you built MCP tools that connected Claude to real external systems with proper authentication and error handling. Month 4, you extracted structured data from unstructured documents at production quality with pedantic validation and confidence scoring. Month 5, you hardened everything: context window management, retry logic, human-in-the-loop escalation, audit trails, and self-evaluation. 3 things to do in the next 2 weeks. First, book the Claude Certified Architect exam at training. Anthropic. Come within 30 days while everything is fresh. Second, complete and submit all 4 month 5 deliverables, aiming for the 75% passing threshold. Third, package the SalonPay support agent as a containerized service, deploy it to Azure Container Apps, and validate it under real load. The skills you've developed over these 5 months: context management, multi-agent coordination, tool use, document extraction, and production reliability, are the foundation of every serious Claude-based production system. You're ready to build them. Audio narrative. Month 5, context management and reliability, Bistec Hearts Academy. Claude Architect track.